Okay, in the zombie activity that everybody got today, or most people got today, the objective is not really obviously about zombies, although that's being used as kind of a backdrop. We talked about in the previous videos, we talked about zombie ants and how fungus can control them and make them do all kinds of crazy things. And not just ants, but other species, right? We've talked about how sometimes diseases, viruses, can jump species, right? So we have this idea that we have a flu in a pig, let's say, and it switches to swine flu in humans. So diseases can jump species, and if we have it in ants, maybe that can then jump to humans, and that leads us to this kind of fictitious situation. Again, fictitious situation where humans then are being zombified by some fungus, and in some way their ability to think and reason is being taken away, and we're left with zombies and this kind of plague that's going around in this particular scenario. So in this scenario, again, there's kind of three states, really four, but three states within the circle that can be happening. You have people can be susceptible to the disease, right? And we're going to call that big S. You can refer to your notes for it. So they're susceptible to disease, which means they can get this, they can contract this fungal infection and then therefore lose their ability to think coherently. When they contract the infection, they're no longer considered susceptible. They have the disease. They're not yet contagious. They have yet to lose their faculties, and we're going to call them the undead, right? They're not quite zombified yet. So they can, from this undead state, they can move on to this zombified state. And of course, ultimately, whether they're susceptible or they're zombified, either way, they can become the classic dead, right? So either the zombie dies or the susceptible dies. Now, what's the point here is that you have a population, and the population is being considered as this kind of susceptible population, and you have a population that's zombified or have become zombies, and then you have like this intermediate state. The question is, at what rate? Remember, we talked about rate. Do these creatures, or these in this case humans, right, in this scenario, in what rate are they able to move from one state to the next state to the third state? So from state 1 to state 2 to state 3, or can they leave the circle? Do they leave the circle? Of course, by leaving the circle, they mean state 4, which is death. Or can they enter the circle? And by entering the circle, of course, they mean birth, right? So we're going to have birth. And birth is only going to happen to the susceptible population. So at what rate is the birth rate? What is the birth rate? What is the rate of people going from the susceptible population, some number, who knows what the number, we're not talking about numbers, we're talking about percentages. We're going to talk about percentages when we're talking about these figures. So the point here is to take a look at this situation, and this situation is analogous to, it's analogous to the pandemic flu that hit, the Spanish flu that hit the world. When I say pandemic, I mean an epidemic at the world scale, right? It's analogous to the Black Plague. It's analogous to the smallpox epidemics throughout our history. It's analogous to the smallpox epidemic that wiped out the Native American population. So in each case, these population changes occurred with a kind of non-disease susceptible population. That would be stage 1. The kind of intermediate population that doesn't show any signs, but they have been infected, that would be stage 2. And then stage 3, the infected state where they are contagious, that would be stage Z, or the zombie situation, or stage 3. Of course, not all the susceptible people, right? Not all of these people here actually became zombified or became infected, became contagious. So this is all analogous to this idea, and we're trying to have a fun way of looking at rates of change, where we can go from a population that has no disease, but they're susceptible to it, to some portion of the population becoming infected, but not yet being contagious, to being infected and contagious. And then, in the case of zombies, you of course have to chop their heads off or whatever. But you can have the disease state dying in whatever way, right? So in the Spanish flu, it would have been dying of the flu, and the smallpox, dying of smallpox, etc. And in the regular population, the susceptible but not diseased population, you're still having people dying of heart attacks, old age, accidents. So those people are also leaving the group. So each one of these is a condition, and each one of these has a rate of changing. So there's a rate of some percentage of these guys are going to get sick, some are going to get the bug. Some percentage of the people that get the bug are actually going to get diseased. At what rate does that happen? At what percentage of these actually become zombies, for instance? And then some percentage of these zombies are going to die. Some percentage of these normal, uninfected people are going to die. And of course, we have new people coming into the population by way of birth. So we're going to look at, this is our opportunity to look at a population and consider birth rate, death rate, infectious rate of a parasitic fungus, and decide what kinds of formulas, what ways can we quantify the changes that occur in these populations. That really is our objective here. All right, I hope this helped. The next video will discuss the actual formulas that we will be discussing in class tomorrow. Only Block 9 really had the objective of finishing question 2. In question 1, you were supposed to work on, and most people got question 1, that's second block, and 5 through 8. You got the task of figuring out, and Block 9 also has to do this. They have to do question 1 and 1 and 2. And in question 1, all you're doing is trying to figure out at what rate does this population actually become infected without showing symptoms, without turning into a zombie in this case. What's the rate? Is it 50%? Is it 30%? Of course, we're going to express those numbers. Remember, we're going to express those numbers in the form of decimals. So it's going to be 0.2 for 20%, 0.5 for 50%, etc. And each one of these rates, this is a rate, the birth rate. This is a rate here. There's a rate here. There's a rate here, the death rate for zombies. There's a rate for the normal. There's a death rate for the normal going to death. And each one has a variable. They're all in your chart. You have to come up with a thoughtful way, way of and there's no wrong answer here, but the only wrong answer is one that you have not put thought into. So what percentage are they going to get infected, become bitten in this case scenario? What percentage are they actually, at what rate, how fast are they going to turn into zombies? And how often are people going to kill these zombies and end up the zombies dying, or how often are people going to die of normal causes and still end up in the state of being that we call death? So birth rate, death rate of non-infected individuals, death rate of infected individuals, infection rate of normal individuals, and disease progress to full-blown infection, again in this scenario called zombie state. All right, I hope this helped. Good luck.